Okay, hello everybody. Once again, this is Mr. Steele, and I'm here to once again review standards from the Term 3 and 4 Algebra 2 Standard Quiz at Franklin High School. This time I'm going to be tackling standard number 4, which is about dividing polynomials. In this video, I'm going to go through exactly 2 examples, as well as talk a little bit about each one. First, I'm going to divide a polynomial using long division in a situation where we have to use long division, although long division will always work. And then second, I'm going to divide a problem where, well, you can't see the problem right now, it's invisible, where you can use synthetic division, so I can talk about and demonstrate that algorithm as well. So to start off with, for our first problem here, the key idea is when we go about doing long division is basically, really it's not even any of these things, it's just using the division algorithm that you learned in 3rd grade about how to divide big numbers. Just to kind of throw it off here on the side, if we're trying to divide something like 45 by, I don't know, 7, basically we ask ourselves first, how many times does, well, let's make this a bigger number. 7 goes into 453. How many times does 7 go into 4? Well, it doesn't, so we can't do it. How many times does 7 go into 45? Well, it goes in there 6 times. And then from there we multiply these two numbers together. 6 times 7 is 42. Interesting how it shows up. Draw the line, change the sign. We'll get a 3. Then we bring down the next number. 7 goes into 33 4 times, because 7 times 4 is 28. Draw the line, change the sign. We will have 5. Since 7 is too big to go into 5, we can just then write it as, we can write that last part as either remainder, or even better, as a fraction. So in fact our answer here, 453 divided by 7 is 64 and 5/7. Well, that is just division. Like that's what I always refer to as the division algorithm. Algorithm is one of those words that really just means a process or a method to do something, but it makes you sound really smart to say it all the time. Like, oh yes, today in class I learned about an algorithm. You sound like you're extremely smart. So, that's basically what we're going to use here. Is we're just going to use this with polynomials. So there might be some little tricks to that, but basically it'll be the same kind of idea. So as far as key factors here, when we get a remainder, it's supposed to be underlining, we're going to do the same thing we did here. We'll put it the remainder over the divisor, just the same way, so it'll almost look like a mixed number. It'll just be a polynomial one. Synthetic division we'll tackle in the second part. And then the missing terms part, it's not necessarily something that's readily apparent, but it basically allows us to make sure everything lines up really nicely. So let's go ahead and look at our first example so that I can talk about that specific piece. So here we go. I've got 4x cubed minus 5x plus 1, and we want to divide that by 2x minus 3. So when we go to set it up, we set up a division, I don't know what this is called, lined, the same way we would in a normal division problem. Then we write in what we have. So 4x cubed plus minus 5x plus 1. And we're going to divide by 2x minus 3. Now, when you look at this, I did leave a gigantic hole, so that might give you a little bit of a clue as to what's going on. But when I look at this, what's going to happen is we're going to see how many times this first term of our divisor goes into the dividend, and then we're going to use that information the same way we would here. We figure out how many times it goes in, multiply down here, and get the next iteration of the division. The problem is if we are missing a term, like if it doesn't go degree 3, degree 2, degree 1, constant, we'll end up with a bunch of disorganized pieces. Like we might have an x squared sitting somewhere next to an x, and we've got to really be careful to keep all our like terms together. So to help myself out, because there's no x squared term, I'm just going to add in 0x squared, because 0 times anything is 0. So in fact we haven't changed the problem at all. We've just added and enhanced our organization. And again, saying things like enhancing your organization in the division algorithm makes you sound really smart, so say it all the time. And okay, here we go. Like we're kind of ready to go. So the first kind of question that we have to ask ourselves in order to start this is how many times does 2x go into 4x cubed? So like what times 2x gives me 4x cubed? Well, with a little bit of thought, the answer is 2x squared, because 2x squared times 2x would be 4x to the 3rd power. And so there we go. We found our first piece. That's going to be part of our quotient. And now, of course, we need to actually get down here and start breaking it up and iterating so we get to another piece. So first, 2x squared times 2x is 4x cubed. We expected that. This is just like the step we did here where we said 6 times 7 is 42. But then we didn't just have to multiply by 2x, we had to also multiply by negative 3. So 2x squared minus 3 is negative 6x squared. Draw the line, change the signs. And the reason we draw the line and change the signs is because we want to subtract whatever it was we just found here, whatever we just took in, and it's a little easier to just remember to switch all the signs rather than remember to distribute a negative sign, so we just do it all in that step. Okay, what do we get? Well, first we get a 0 there, just like we want. Over here we're going to get 6x squared, and then we will bring down the next term. Okay, next piece. How many times does 2x go into 6x squared? Just like we asked ourselves, how many times does 7 go into 33? Well, 2 goes into 6 3 times, positive 3 times in fact. So this would be positive 3, x goes into x squared x times. So we know this is going to be positive 3x, and now we multiply it times the divisor and get our new line down here. 3x times 2x is 6x squared. That's what we wanted. Positive 3x times negative 3 is negative 9x. Once again, draw the line, change the signs. We'll get a 0 right here. Negative 5x plus 9x is 4x. Carry down the next term. Poor carry down there. So we'll have 4x plus 1, and finally we go to our last little piece here. How many times does 2x go into 4x? Well, since it still goes in, we can answer that question. The answer is going to be positive 2. And then we go back and do the next line just like we have twice before. Positive 2 times 2x is going to be 4x. And positive 2 times negative 3 is going to be negative 6. Draw the line, change the signs. 0. We get positive 7 down here, and, well, when we reach this point, 2x can't go into 7 anymore. The degree up here is 1, the degree down here is 0. Like, they can't go into that unless the degree is the same, or well, the degree has to be either the same, or we've got to be going from smaller degree into a bigger degree term. So, in fact, this is going to be our remainder, like it's staring at us right there. Remainder. Won't write rem because that's a type of sleep. And so, of course, what do we do with the remainder? Well, we're going to write it up here like a mixed number. The difference is we can't just write it next to it because it's not understood the same way in with polynomials. Instead, we have to put a little plus sign. Say we're going to add on one little extra term. It's an ugly plus sign. And then we take our remainder itself, right there. That remainder was 7, and we put it over our divisor, which was 2x minus 3. So our final answer here, the quotient of those two, oops, I don't know what that was. The quotient is 2x squared plus 3x plus 2, all plus, ooh, that was fancy, looked like a rhinoceros 7, plus 7 over 2x minus 3. And voila. There is the quotient of those two polynomials. So to kind of reiterate what we did was we spread it out. We filled in a missing term with just a 0 spot just so we could keep everything really organized. We did the normal division algorithm, asking questions like how many times does bleu go into bleu, and then drawing the line, changing the sign once we'd multiplied that piece together, or multiplied it in, and then finally when we found our remainder, we added it over the divisor to our polynomial. So we got through this first long division problem. And again, I didn't make a big deal of it, but this is called the long division version. Like, this is one way to solve the problem. And in this case, since there's a number in front of the x, like, we have to use long division. And so there we go, long division. What about another kind of division? Let's see. Okay, so that was long division, which always works when we're dividing polynomials. But in fact, there's actually a method that'll work a little bit easier when we have a special setup. And that method is what we see over here, synthetic division. Synthetic division only works, so let's make a note of this just so it's clear. Synthetic division only works if our divisor meets a specific condition. If, sorry, I'm trying to spell, divisor is x plus or minus some sort of number. So we can't have any number or coefficient in front of the x in our binomial term. So in fact, x plus 2, what we have here, is going to work out nicely for synthetic division. If you look at our original problem, 2x minus 3, fail, doesn't work. So what synthetic division is going to look like is it's going to look kind of bizarre. It doesn't look like the division algorithm, even though it's going to accomplish the same thing. And it's going to start by creating what I call a pivot table. I don't know why I call it a pivot table, but somewhere along the way I was led to believe that that was what it's called. And so the pivot table basically looks like this. you create a little corner to put the pivot in. We'll talk about where to get it from. And then you leave a little space, and presumably you draw a straight line. Curved lines are also okay. I guess I'm stuck doing a curved line. There we go. And then what we're going to do is we're going to fill in the coefficients, like just the coefficients, the numbers in front of each of the x parts from our original equation. So first we'll fill in the coefficient of the x cubed term. It's going to seem redundant to write it here, but when you're doing it on a test or a quiz, it's sometimes helpful. We'll have to write in the coefficient of the x squared, the coefficient of the x, and then the constant. And then when we do division, because we're dividing by x to the first power, we're going to end up with an answer that has an x squared term, followed by an x term, followed by a constant, followed by a remainder. Now, as far as where we get the rest of the stuff, like what we do to fill this in, we start by putting the pivot up here. So that's going to be the pivot itself. Again, I don't remember why I call it this. Hopefully it's still an acceptable method. So to find the pivot, we look right in here. So the pivot is whatever makes the divisor equal to 0. So let's write that in here. Makes divisor equals 0. So as we go up here, we look at it, we go, okay, well, what makes x plus 2 equal 0? Well, you can pretty much clearly see that that's going to be negative 2. You can subtract 2 from both sides, we get x equals minus 2. So up here, we're going to write negative 2. That is our pivot. And again, its meaning has to do with the fact that it's a 0 of the function, because that's, or we're testing to see whether it's a 0, like that kind of stuff. Next, what we need is we need the actual coefficients from up here, right down here. So on this line, we'll need coefficients. So we look at our first one, the coefficient of x squared, there's nothing there, so it's a 1, a positive 8, a negative 2, and a 14. And so now we actually have everything set up to do the actual synthetic division. So I'm just going to change pen color so it's a little clear what I'm doing. Okay, so now what do we need? Well, here we go. We need to start the actual synthetic division. So first, we take the first coefficient, we just bring it down straight up. Just do that every time, bring it straight down, whatever that one is. The reason is, if you look at the actual division, our first piece is going to be dependent on how many times that first term goes in. So it actually just kind of takes care of that. We don't have to do anything fancy for it. So in this case, we bring down a 1. Then we take this number, whatever our value is down on the bottom, and we multiply it times the pivot. So in this case, in order to get up here, we're going to multiply 1 times negative 2 is negative 2. So we're just multiplying by the pivot that way. So what you'll kind of see is the pattern is that you add going down, and then you multiply by pivot going up. Mult by pivot. That's really all we're doing. Just kind of following a pattern. So from here, 8 plus negative 2. So when we go down, we add. 8 plus negative 2 is 6. Then we once again multiply by the pivot. 6 times negative 2 is negative 12. So negative 2 plus negative 12 is negative 14. One more time we have to multiply by the pivot. Negative 14 times negative 2 is 28. And now lastly we add going down. There's my arrow. 14 plus 28 is, lo and behold, 42. And so we have just done or accomplished the division. There's just two problems. One, it's doesn't seem as clear that we were doing division, and two, what is our answer? Well, our answer is actually right here. Like, we're staring right at it. Our answer is going to be, these are going to be the coefficients of our actual polynomial and remainder pieces. So in this case, our answer is going to be 1x squared, or just x squared, plus 6x, minus 14. And then for our remainder, it's remainder 42. So to do that, we do just like before. We do plus. Our remainder is 42 over the divisor itself, and this was our divisor. So the divisor is x plus 2. And so our answer, our final quotient, is that the quotient of x cubed plus 8x squared minus 2x plus 14 divided by x plus 2 is x squared plus 6x minus 14 plus 42 over x plus 2. And so this is a method, again, it has to meet specific conditions, like we can only use synthetic division if it meets this qualification, if we have the right kind of divisor. But basically, once we've got it, synthetic division lets us find our quotient just the same. So to quickly recap what we covered, we talked about dividing polynomials for standard number 4. We started with the long division method, taking note of the fact that a missing term can cause havoc unless we kind of give a space filler or to add space in there for it with a 0. Then we just use the normal division algorithm from 3rd grade with the little x's instead, and then use things like draw the line, change the sign, how many times is blah, go into blah, that kind of stuff. And then finally, if we had the specific kind of problem, a problem with the special kind of divisor, we were able to use synthetic division, which uses a pivot table and the coefficients from the original problem, and we were able to divide it just the same. And if you don't trust this, of course, just use long division. Long division always works, whereas synthetic division is kind of restricted, but your answers should work out just fine. So hopefully this video has been helpful too. Standard 4 polynomial division is one that you can succeed on and excel at. And then once again, to end this night of video making, it's Mr. Steele signing off. Have a good night, everybody.